Hello everyone, welcome to our new video. We're going to talk about arithmetic operators, relational operators, and some intro to decision-making statements today. So let's start. In the first video we talked about variables, and we didn't mention that the specific features of variables like global variables and local variables. So what is a local variable? Local variable is basically a variable which is defined in a function. For example, it doesn't have to be always a function. It can be a block. For example, we have a main function in here. In main function we define an, for example, integer x. And this integer x is local in this main function. For example, if you can't try to call this integer x from another function. For example, integer maximum function. Zero. Let's try to call this function from. Let's say cout x. By the way, in the first video we used std cout like this, std cout, and in this video as you see we using namespace std. And if you declare that you're using namespace std, and you don't have to use std in front of any identifiers that defined in the libraries before anymore. So you can keep in mind that for now. We're going to explain that in the later videos. So we define the x in the main function, but we call it in the max function. So let's call max here, and let's clear this, compile our second lesson, CPP second lesson. Alright, so it says that x was not declared in this scope, an unused variable in int main. So it's not declared in this scope. What is the scope? It's the brackets. Between the brackets we have a function block. The function block means scope of that function. So if we define integer x in here, for example x equals 5, and print out to x in here, then no longer we don't need anymore. So we call it max. We compile that. Second lesson. So it prints 5, as you can see. Because this x is now the local variable of the max function. Now you can call it in it here, but you can call it from main or something else. But if you want to call it, for example, we declare the integer x in here, but we wanna do some operations in a max functions block, then you have to pass the x value in here. For example, x is the parameter of this argument of the max function, and you have to integer blah blah. But we're going to get to this point in the later videos. The functions and call by values, call by references are topics of other videos. So I'm deleting this right now. You shouldn't be confused about that. So I'm just trying to explain the local variables and global variables. And what is the global variables? Since we defined the int x in the block of the main function, we call it from there. But if we define any variable like integer x equals 5, we can call it from anywhere we want in our program. For example, let's say cout x. As you will see, it it won't give an error to us as x is not declared in the scope. Let's compile that and run that. So as you can see, x is now a global variable and it does not belong to any scope, so it can be called from any functions block. We're calling the x from main. So 5, yes. So local variables and global variables are like that. Now I want to mention about some arithmetical operations like plus operation, multiplying operation, subtraction, or division, or remainder, like that. So let's say we have integer x equals, let's say 10, and integer y equals 5. So you can set results equals x plus y, and let's put that in here, count the results. So it becomes 10 plus 5 equals 15. Let's check it. Yeah, as you can see, it's 15. And also results equals like that, multiplying two integers 50 and division of two integers. Divided by 5 is equal to 2. So let's come to, the subtraction, let's come to the remainder. So if we divide 10 by 5, the remainder must be, as you know, 0. The percentage symbol gives the remainder. So by this, I want to make some, or maybe later, never mind, okay. These are the arithmetical operations. And there are relational operations, like for example, x equals or not y, or this statement, or a greater than, x greater than y, or x smaller than y, goes like that. So for example, this statement here is just returns Boolean. I mean, if x equals y, it returns true. If it's not, 0. Let's check that out with an example. Let's say result is Boolean type, and we are going to check if x equals y or not. It's not an assignment like this, x equals y. If we say x equals y like this and comment this out, what it will be right? We are assigning x to y to x, so x will be 5, and we're going to print the x, and we see the assignment here. Then here x and y are 5. So if we take this result as this, now x is 10 and y is 5, and this statement checks, this operator checks if x equals y or not. 10 is not equal to 5, so then it returns false. Yeah, as you can see, it returns 0. And if it, for example, x not equal to y, it checks this operator checks if x not equals to y or equals to y. If it's not equal to y, it returns true. If it's equal to y, it returns false. For example, not equal to y in our case right now. So it will return 1 as true. 1 means true, 0 means false. And these are the arithmetical operations, or we can, these things are the same. X smaller than y, it must be returned 0 because 5 is smaller than 10. And also we can check, let's say it is 10 and smaller or equal to, let's compile that, and it returns true because x is smaller or equal to y. Then we have assignment operations like x plus equals y. What it does is, it is the same as, we can write it as x equals x plus y. So we sum up these two numbers, x and y, and assign to x. This is the short abbreviation of this operation. You can write it as like that. So we sum up x with y and assign it to x, as you can see right here. Right now, if we print out the x, you're going to see 20 as a result. 20, yes. So another assignment operation can be multiplier. Let's compile it. Yes, hundreds, and can be a division as well, or remainder as well. All arithmetical operators can be applied to this as well. So yes, that's the assignment. We mentioned about assignment operations. So we have now logical operations. And when we are getting to logical operations, before we get there, I want to mention about, do some intro about if and else statements. So if and else statements, and also we have a switch statement as well, help us making decision in program. So what I mean by that, we can have x equals 10, or if you wanna, if you can state them in one line as here, there's no problem. You can, you mustn't have do them in separate lines. So let's give an example. What are logical operations? This is AND in logic, AND symbol in logic, or and not. Yes. For example, if x equals y from our relational operations, if you have one statement to write, for example, cout, they are equal. If you have one statement after the if or else if, whatever, you can, there's no obligation to take them in brackets. You can write like this. one tab, and this will work. Oops. X, oh, we made it. Yes. Oopsie. On 10. I couldn't see what I'm doing wrong, so right now we should keep them, or we should keep them like another. Alright, we set them different. Now, as you can see, x and y are not equal, so if x equals y, we are going through into this ifs block, as we mentioned in the first lesson. If has a block too as functions. So if x equals y, we get into this block and see out they are equal, but we couldn't print this statement out because x and y are different. X is 10 and y is 5. So you can change that. If x not equals to y, print that. Yes, compile it. And second lesson, they're equal. Of course, they're not equal. We should make that they're not equal, as they're not equal. So yes. And we can combine these with else if. For example, if they are equal, we can set that else if x not equal to y. This statement will be the block of we're going to get into the block of else if this statement is wrong. If we don't go in the ifs block, we go into the else block. So they are not equal. Let's check that out. We got some problem about terminal. So desktop, C course, less. Yes, we compile it and run it. As you can see, x and y are not equal, because we get into the else's block here. But maybe if you wanna do more than one, for example, if they're not equal, we wanna print they're not equal, and also make them equal. For example, if x equals y, then you have two lines. So you gotta get the block in brackets, and you should write down it here. We make them equal. So now both x equals y equals 5 if x equals y. Let's make it with the brackets. So see out they are equal. So let's check that out. Let's compile that, run that. Yes, we should put here an end line states, then it looks more good. second lesson. First, they're not equal, and in the second line of the if block, we assign y to the x, and then become equal. Both x and y are 5. Then we get to do x if x equals y. They're equal because both of them are 5, so they're equal. We print it out. So yes. And there's another type of, we can do this like that. We have an else too, like for example, let's say we have x equals 10, and if x smaller than 10, we print smaller. Else if x greater than 10, we print greater. Let's put the end line here. And else the remaining, if x not smaller than 10 and also not greater than 10, then x equals to 10. So else is like default option for us. So we're going into if it's not true, we don't get in the if block. Then we check the else if block. Then if else if blocks are not true as well, so we get into the else block. So the remaining option for us, x equals to 10. X equals to 10, right? Yes, we just got into the else block. So after if and else, we have, or we can talk about ternary. So for example, before the ternary, I want to mention about the new library. We're going to dig deep about it in further videos, but you can now understand what is going on here. So string, it's just another data type that we have in C++, but just I didn't mention about it in the first video. So you can think about it like a string. It's just an array of characters. String, for example, word equals, let's say, words, let's say none. So it's just like that. You can print out the words as yes. You can print out our word like that. So now what I want is we're going to have, and for example, it's 8. Instead of writing this block, for example, let's make this if x is smaller than 10, 5, do this. Yes, it was smaller, that was right. 5. So instead of this, we're going to declare our decision-making statements like in a one line, just a more simple way. For example, we define results, string results, as just a string results. Yes, it's going to keep our smaller or greater statement, the solution, I mean. So string results. So the first is our condition, our check. What we do check is going to paste in here. So if x smaller than 5, we put question mark in here. We're questioning this. Is x smaller than 5 or not? We're questioning that. So question mark. And after that, if it's true, let's write that like, if it's true, 1. We write it here. And if it's not, for example, if x smaller than 5, we wanna keep the smaller word in the result, and we keep the symbol in here. And if it's not, then it's greater than. So we have x as an 8. Let's comment this out. These are going to be same. So let's write here as 0. In one condition we get smaller, in 0 condition, I mean false condition, we get greater. And then cout results. So, and run that greater. So 8 is greater than 5, so it gets 0 and greater. Yes, this statement, this type of statement called ternary. Yes. So we can comment that out as well. Yes. So another thing, another decision-making block or type we can use to ease our work is switch case. For example, we have int x equals, or we can say hour, or int clock equals 20, or yeah, we can say 20. For example, switch clock. We're going through the cases for clock, which we write in switch parentheses, between parentheses of switch. We're questioning the clock's cases. For example, if it's case clock, for example, case clock is smaller than 10, 12, let's say 12. I guess we do it. Then cout, it is morning. Case clock, let's say 16 or 18. Cout, by the way, in each case block we should break from the cases, yeah, and it is evening. Yes. So as the default, we have a this default case. We're going to execute it we're going to execute it if none of our cases is working. So as default, we can print out it's me. For example, I'm just making up this. It's midnight. It is midnight. Yes, and break from that. So yes, let's check this if I'm not miswritten something. Yes, I'm writing something right, not right. It is like, no, it must be something like that. Yes, I guess so. No, int clock is not const. Switch. I'm doing some mistake in here, so let's check the switch statement. Case 1. Yes. Oh. Yes. If it's clock, switch clock, it is midnight, it's evening. So I don't know if there is a comparison. There's a way to compare the clock to be in the interval or not. I don't know, but we can check. We can do it by if clock equals 20. For example, sorry, if clock equals 8, it's morning, but clock equals 20, it's evening, or clock equals 24, it's midnight, like that. So our clock is 20 and it must be midnight, sorry, evening. So no, default, not a default. Yeah, let's set the default by it's midnight. Yeah, and run that. It's evening, so the clock is 20, and in case 20 we print out its evening statement. Yeah, so we mentioned about some local variables and global variables, and also operators like arithmetic operations, relational operations, assignment operations, and logical operations which help us in the decision making with if and else blocks or switch blocks. So that was an intro about then if and else and switch blocks. So thank you for watching. Thanks for all. Goodbye.